Bismillahirrahmanirrahim and Assalamu alaikum. I hope that you all are doing well. This is day and week 4 of class 9th physics, and today we are going to solve the remaining numerical problems of unit number 5 named as gravitation. It's on page number 116 of your textbook. So let's start with the problem number 5.6. The statement is find the value of g due to Earth at geostationary satellite. The radius of geostationary orbit is 48,700 km. So firstly we have to find the value of g. The radius is mentioned here. I'll remove the prefix of kilo as 10 raised to the power 3. Now for the value 48,700, I'll write the point 0 and move the point towards the second non-zero digit. Because I'm moving the point towards the second non-zero digit and I have covered 3 digits, that's why I'm writing it as 10 raised to the power 3. Why I haven't moved it towards the first non-zero digit? Because when we combine these two bases and write the power, it will be 10 raised to the power 6 and it will be more easy to solve. For mass of the earth, we know that it's 6.0 multiplied by 10 raised to the power 24 kg, and the value of g is 6.673 multiplied by 10 raised to the power minus 11 Newton meter square per kg square. We can find out the value of g by the formula g is equals to gme divided by r square. So by using the values from the given data, the equation will be like this. Now as you can see here, 6.673 multiplied by 6.0 will be equals to 40.038, and because the bases of these two values are same, so I'll write the base once and add the powers. So 24 minus 11 will be 13, and when you take square of 48.7 multiplied by 10 raised to the power 6, it will be 2371.69 multiplied by 10 raised to the power 12. So now moving on to this equation, because the denominator and the numerator both have the same base, to move the denominator towards the numerator, I'll change the sign. So it will be 10 raised to the power minus 12. Now bases are same, I'll write the base once and add the powers. It will be 13 minus 12. And when we divide these two, we will get the answer as 0.0169. 10 raised to the power 13 minus 12 will be equals to 10 raised to the power 1. So multiplying 10 with 0.0169 will be equals to 0.169. Because as you can see here, 9 is greater than 5. So we will increase one value in 6. It will be 0.17 meter per second square. So as we know that g is the gravitational acceleration and the unit of acceleration is meter per second square. So the answer will be 0.17 meter per second square. Next problem we have here is the value of g is mentioned as 4.0 meter per second square at the distance of 10,000 km from the center of the earth. Find the mass of the earth. So the radius is mentioned as 10,000 km. The gravitational acceleration is 4.0 meter per second square. Because as you can see here, there are 4 zeros along with 1, so I'll write it as 10 raised to the power 4. And we know the prefix of kilo is 1000, which is 10 raised to the power 3. Bases are same, powers will be added, and the value we'll get is 10 raised to the power 7 meter. We have to find out the mass of the earth. The formula of the mass of the earth is me is equals to gr square divided by capital G. We know the value of capital G is 6.673 multiplied by 10 raised to the power minus 11 Newton meter square plus per kg square. So I'll use the given data and put it in this equation. So we will get the equation as this. By taking the square of 10 raised to the power 7, we'll get it as 10 raised to the power 14. Now I will move the denominator towards the numerator. The sign of the power will change. It will be 10 raised to the power plus 1. Bases are same, I'll write the base once and will add the power. It will be 10 raised to the power 14 plus 11, which is equal to 10 raised to the power 25. 4.0 divided by 6.673 will be equal to 0.599. Now, for this, I'll move the point towards the first non-zero digit. It will be 5.99 because I'm moving the point towards the right hand side, so the power will be negative. So it will be 10 raised to the power minus 1. And bases are same we will do here is I'll write the base ones and add the powers. 25 minus 1 will be equal to 24, and it will be the mass of the earth, which is approximately equals to 6.0 multiplied by 10 raised to the power 24 kg. Problem number 5.8. At what altitude mean height, at what altitude the value of g would becomes 1/4 than the radius of on the surface of earth. As we have discussed this in variation of g with altitude, that at a height of 1 earth radius, the value of g becomes 1/4 of its value on the surface of the earth. So we have a numerical here. We will solve it by using our data, and we'll get the height, same height, which is 1 earth radius. So let's solve it. As we know that the mass of the earth is 6.0 multiplied by 10 raised to the power 24 kg, and the radius of the earth is 6.4 multiplied by 10 raised to the power 6 meter. And they said here that value of g is decreased by 1/4 on the surface of the earth. So gh will be equals to 1/4 into g. Value of g is 10 meter per second square, so I'll write 10. So 10 divided by 4 will be equals to 2.5 meter per second square, and we have to find out the altitude or height. Now we know that by using the variation of g with altitude formula, that is gh is equal to gme divided by r plus h square. To find the height, I'll shift the r plus h square towards left hand side and gh towards the right hand side. Now by taking square root on both sides, it will be r plus h is equals to under root of gme divided by gh. Because we have to find out the height, so r is adding in h. If I move it towards the right hand side, it will be subtracting. Now we know the values of g, me, gh and r, so I'll use the data and put the values in this equation. As you can see here, by multiplying this 6.673 to 6.0, it will be 40.038, and by multiplying these two, that is 10 raised to the power minus 11 into 10 raised to the power 24, we'll write the base ones and add the powers. It will be 10 raised to the power 13. Now by dividing 40.038 to 2.5, it will be 16. And as you know that I can't take the square root of odd number, the odd power, that is 10 raised to the power 13. So I have to convert it into a even power. So what will I do? I will simply write it in 10 raised to the power 1 and 10 raised to the power 12 form. Because if we will solve it, it will be again 10 raised to the power 13. So by multiplying 10 raised to the power 1 with 16, it will be 160. Now I can take the square root of this value. It will be 12.64 multiplied by 10 raised to the power 6. Because the powers are same, so we can write the powers 1, and subtracting 12.64 minus 6.64, it will be 6.24 multiplied by 10 raised to the power 6. And as we know that 1 earth radius is equals to 6.4 multiplied by 10 raised to the power 6. So it is approximately equals to 1 earth's radius. 5.9. A polar satellite is launched at 850 km above the earth. Find its orbital speed. We know that the formula of orbital speed at a height h is equals to v naught under root g into r plus h. So the height is mentioned here as 850 km. I'll move the point here. It will be 0.85 multiplied by 10 raised to the power 3. Why am I doing it? Because it is more easy to solve. The prefix of kilo will be 10 raised to the power 3. So 10 raised to the power 3 and 10 raised to the power 3 will be equal to 10 raised to the power 6. And we have to find out the orbital velocity. Now, we know the formula. And we also know the value of g, the formula of g is equal to gme divided by r plus h square. So I'll put this formula in equation number 1. It will be like this. So what will I do? I'll cut the square with this r plus h. The equation will be under root of gme divided by r plus h. We know the value of g as the mass of the earth and the radius of the earth as well. What we need to know is h, and it's mentioned here. So by multiplying again these two, we will get 40.038, and by multiplying these two, I'll write the base ones and add the powers. 24 minus 11 will be 13. We'll shift the base from the denominator towards the numerator. It will be 10 raised to the power minus 6, because when you move the value from the denominator towards the numerator, its power will change. 40.038 divided by 7.25 will be equals to 5.522. So I can't take the square root of an odd number. So what will I do? I'll convert it into even number. So I'll separate it like this: 10 raised to the power 1 into 10 raised to the power 6. I'll multiply 10 raised to the power 1 with 5.522. It will be 55.22. And when I'll take the square root of this value, it will be equals to 7.431 multiplied by 10 raised to the power 3. By multiplying 10 raised to the power 3, which is equals to 1000, to 7.431, it will be equals to 7431, which is 7431 meter per second. Because I was finding the orbital speed, so the unit will be meter per second. Last numerical for today is 5.10, and it's stated as a communication satellite is launched at 42,000 km above the earth. Find its orbital speed. This numerical is also same like the previous numerical. The height is mentioned. I have to firstly remove the prefix of kilo, and then I have to shift the point towards the 3 digits towards to the second non-zero digit. It will be 42.0 multiplied by 10 raised to the power 3, because I'm moving the point towards 3 digit towards the second non-zero, and the kilo prefix will be 10 raised to the power 3. So the answer we will get here will be equals to 42.0 multiplied by 10 raised to the power 6. Orbital speed is we have to find. Same, we know the formula that for orbital speed V naught is equals to under root of g into r plus h. R is the radius of the earth, g is the gravitational acceleration, and we know the formula of gravitational acceleration is equals to gme divided by r plus h square. So I'll cancel these two, and we will get the equation as under root of gme divided by r plus h. Same, we know the formula of universal constant of gravitation as 6.673 multiplied by 10 raised to the power minus 11. Mass of the earth has 6.0 multiplied by 10 raised to the power 24, and radius of the earth has 6.4 multiplied by 10 raised to the power 6 meter. Plus height is mentioned here, which is 42.0 multiplied by 10 raised to the power 6. Now by adding these two, I'll get the answer as 48.4 multiplied by 10 raised to the power 6. And by multiplying these two, I'll get it as 40.038 multiplied by 10 raised to the power minus 11 and multiplied by 10 raised to the power 24. Bases are same. I'll write the base ones and add the powers. It will be 10 raised to the power 13. Move the denominator's power towards numerator. The sign will change. It will be 10 raised to the power minus 6. And same with this case, I'll write the base ones and add the powers as 13 minus 6, which will be equal to 10 raised to the power 7. Now again, I can't take the square root of the odd power, so what will I do? I'll simply separate it and convert it into an even power. So it will be 10 raised to the power 1 multiplied by 10 raised to the power 6. Multiplying 10 with 0.827, it will be 8.27. Now taking the square root of this equation, of this value, I'll get it as 2.8757 multiplied by 10 raised to the power 3. When I'll multiply it by 10 raised to the power 3, which is 1000, it will be 2876, that is 2875.7. And because 7 is greater than 5, so I'll just add one digit in the previous value. So the answer of orbital speed will be 2876 meter per second. So these are the numerical problems for today, and same with this case, the assignment you have here is to solve the numerical problems, to do the written practice of these numerical problems. Hope that you understand it. Allah Hafiz.